Now let's talk about problem 2. From the problem, we know that the random variable x is uniform in the interval from -1 to 1. And we know the density function of y. Meanwhile, so first, because the variable x is a uniform function, so we can write the density function of x. It's like this. When x belongs to -1 to 1, the density function of x equals to 2 over 1. And the density function equals to 0 otherwise. And now, from the density function, we can get the distribution function of x. So we can know the distribution function equals to 0 when y less than -1, and it equals to 1 when when x is more than 1. And then we can know because x is uniform, so from -1 to 1, the distribution function equals to 2 over x minus x plus 1. And now we can write the graph of the distribution function x. It's like this. When x is less than -1, is equals to 0, and when x is more than 1, is equals to 1, and from -1 to 1, it equals 2 over x plus 1. And we also know that the density function of y equals to e to the power minus y multiply uy. Now we can get the distribution function of y equals to this: 1 minus e to the power minus y multiply uy. So we can draw the graph of distribution function of y. So the distribution function of y is like this. Because of the uy, so when y less than 0, it equals to 0. And when y is less than 0, the distribution function is 1 minus e to the power minus y. It's like this. So now we can count gx. Let the distribution function of x equals to the distribution function of y. We can count that y equals to minus ln 2 over 1 minus x. This is gx. But we know that is only for x from -1 to 1. So for x from -infinity to -1, gx equals to 0, and it is similar. So when x is less than 1, gx equals to infinity.